Hey, what's up, guys? I am Bysisa. So today's episode is going to be on absorber. So absorber, it is a unit operation used in chemical industry which brings gas and liquid phases in contact. So this is a problem statement giving a carbon dioxide has been absorbed in the propylene carbonate in trace. The inlet gas stream is 33 mole percent of carbon dioxide and also 77 mole percent of methane. The gas stream flows at the rate of 100 kg per hour, and the column operates at 59 degrees Celsius at a pressure of 60 atmosphere. The inlet solvent flow is 100 kg per hour and at also 100% composition. So it's asked to determine the concentration of each component in the outlet stream. The property to be used is PR. So let's proceed to the high-stress environment for the simulation. So we add our component. So I have methane. I also have carbon dioxide. I also have propylene carbonate. So the property to be used is this is the property to be used, that is PR. So let's add our fluid package, that is the equation of state. So let's scroll down. This is it. A green color will be shown at the bottom of the interface, identify you that a certain equation of state has been selected at a fixed condition. So let's proceed to the simulation. I have two streams. So the first stream is solvent in. So let's check the data. It operates at 59 degrees and 60 atm at 100 kg per hour. So I have 59 degrees Celsius. At 60 atm. Then the molar flow is 100 kg per hour. The unit has to be consistent. So we now proceed to composition. So our solvent is propylene carbonate and it is 100%, that is 1. So we add another material stream, and this time around it is gas. So let's give it a name as gas in. They operate at the same condition, that is 59 degrees Celsius and also 60 atm. But ratio, okay, let's insert the parameters first. I have 59 degrees Celsius. I have, okay, is it 59? Let me check. Then I have a pressure of 60 atm. The flow rate is 100 kg per hour. The unit has to be consistent. So let's go to composition. Let's go back to the data again. So this is the mole percent, the mole ratio. For CO2 I have 23 mole percent, and for methane I have 77 mole percent. So methane, this is 77 mole percent, that's 0.77 For CO2 I have 0.23. So we now go to the columns and select our absorber. This is absorber column. So our solvent in is the material stream at the upper. This is our gas out. This is our liquid out. So let's check the pressure. The pressure is 60 atm. The pressure is 59. I mean the temperature is 59. The unit is in degrees Celsius. So the question asks is determine the concentration of each component in the outlet stream. So let's go to the worksheets and composition. So the gas out, the composition of methane is 0.8269. In terms of percent, I have 82.69%. For carbon dioxide, I have 0.1730. So in terms of percent, I have 17.30%. I have propylene carbonate is 0.001. So in terms of percent, I have 0.01%. This is for gas out. That is the gas out. For liquid out, I have 0.582. For methane, I have 0.0721. For carbon dioxide, for propylene carbonate, I have 0.8698. So in terms of 100%, for methane, I have 5.82%. For carbon dioxide, in terms of 100%, I have 7.21%. In terms of carbonates, for the liquid out, it is 86.98%. So if you could recall, initially I have two streams. The first stream is the solvent in, which contains propylene at 100% in terms of ratio. That is the solvent in, and in the gas stream, initially I have two constituents, that is methane and carbon dioxide. So methane contain 77 mole percent and carbon dioxide contain 23 mole percent. So the gas out, here I have methane contains a higher ratio, followed by carbon dioxide, then the least is propylene carbonate. So in terms of liquid out, the ratio of propylene carbonate has to be higher than the its counterparts, methane and carbon dioxide. The reason is, initially for the solvent I have methane to be the solvent propylene carbonate is to be 100 mole percent, so that is why it has to take more ratio than the other counterpart. So here the liquid I have 86.98%, followed by carbon dioxide, then the least is methane. So this is it, how to determine the composition of the outlet streams as long as the parameter given satisfy the equation of state. Make sure to subscribe so that for the upcoming episodes you'll be in touch. Thank you for watching. See you in the next one.